Hi, and welcome to this Mometrix video on equations and inequalities. In this video, we'll talk about their similarities and differences, what they mean, and we'll break down, in a way that's easy to understand, the sometimes confusing inequality signs. So let's start with a basic question. What's an equation? Here's a very simple way to think of an equation. An equation has an equal sign, like this. 2 plus 2 equals 4. When you see an equal sign, you know that math problem is an equation. It is saying that two or more things are equal. Those things can be simple or complex. Here's an example of a simple equation. 10 plus 2 equals 6 plus 6. As you can see, the answer on both sides of the equal sign is 12. The equation says that the sum of the numbers on the left side, 10 plus 2, equals the sum of the numbers on the right side, 6 plus 6. Equations can be complex, but at their core, either side of the equal sign remains true. Let's break down this more complex equation using this example as a base. The answer on both sides of the equation is 17. Let's break it down. 5 times 2 is 10, divided by 2 is 5, plus 10 plus 2 is equal to 17. And on the other side, 10 divided by 2 is 5, plus 6 is also 17. That's a simple look at equations. Let's look at some key terms regarding algebraic equations. An algebraic expression is the problem you're trying to solve. X plus 7 equals 14 is a simple algebraic expression. These expressions contain numbers, variables, and an arithmetic operation that can be as simple as addition or subtraction or as complex as a square root multiplier. A term is at least one number or variable multiplied together, though terms can have more than one number of variable. For example, 2x minus 4x equals 20. The 2 and the 4 are numbers, while x is the variable. Coefficients multiply variables. So let's take a look at 6x, which means 6 times the variable x. Therefore, the number 6 is the coefficient. Constants are numbers whose values don't change. The values are fixed. Let's look at n plus 5 equals 9. The values 5 and 9 don't change, so those are the constants. Constants can also be variables that stand in for fixed numbers. Like terms have the same variables and exponents. So 5xy, 6xy, and 9xy are like terms because they all contain xy. Exponents are the simplified method of multiplication. The 3 in x cubed is an exponent. It's much easier to write and read this than to write and read this. Inequalities also have a large part in algebra. While equations mean two things are equal, inequalities, as you might have guessed, show that things are not equal. These are the 5 inequality signs. Greater than or equal to, less than or equal to, and not equal. So, in simple inequality terms, 8 is less than 16, 15 is greater than 9, and 6 does not equal 5. Expressed algebraically, you might see this. X is greater than n plus 7. Equations and inequalities are similar in some ways, but pretty different in others. Let's start with the similarities. You can multiply and divide numbers in inequalities in almost the same way you can when working with equations. Here's an easy example. 9x plus 10 is greater than 3x plus 4. Equations are true. In other words, the value after the equal sign is absolute. There's no dispute that 10 plus 10 equals 20. With inequalities, there are more possible outcomes since there is an infinite number of possibilities for numbers that are less than and greater than. Negative numbers work differently. This is where it gets a little bit complicated. Anytime you use a negative number to multiply or divide an inequality, you have to flip the inequality sign to keep the equation true. For example, 4 is greater than 3. We know that's true. So let's expand on both sides a little bit. 3 times 4 is greater than 3 times 3. In this case, 12 is greater than 9. Once again, that's true. But if we multiply with negative numbers, things change a little bit. So let's have our equation multiply both sides by negative 3. So you have negative 3 times 4 is greater than negative 3 times 3. But that then becomes negative 12 is greater than negative 9. And that's not right. We know that negative 12 is not greater than negative 9. That's why you have to reverse the inequality. If you don't, the problem won't be true. So reversing the inequality results in negative 12 is less than negative 9, which is true. So that's our look at equations and inequalities in algebraic equations. Equations present a true value while inequalities can have any number of outcomes. I hope this overview was helpful. Thanks for watching and happy studying.